Welcome back. In today's video, we're going to talk about basic object-oriented programming, encapsulation, setters and getters, and eventually also properties. So, to understand object-oriented programming, it might be helpful to imagine something like a person. So, what does a person have? A person has a name, an age, presumably, perhaps even an occupation, or something else. There are a lot of features to a person, a lot of fields, if you will, a lot of characteristics. But each person is different. There's this concept of a person, right? And each individual person is an instance of that concept. So, to do this, we can create ourselves an object called person. Now, there's a couple ways to create an object that doesn't already exist. One way is to go person, and then we could say Dave, for instance, equals new person, like this. Of course, it tells us it doesn't exist. That's the glory of Visual Studio. It will tell us these things. But we can click on this and say generate class person in new file. So as you can see in our Solution Explorer, we have a person.cs now. Let's get rid of what they did right here. They did internal. Let's not do that. Let's replace that with public. Internal is a very specific keyword to C#, and I don't consider it to be that important to what we're doing. As you can see, it automatically gave us this namespace. Strictly speaking, for object-oriented programming in C#, you don't need to have this namespace thing, but it's an extra form of organization, and it's not too bad to have, so we'll have it. So as you can see, we have a person, we have a variable of type person, which is equal to a new instance of person. When we say equals new person, it's calling the default constructor for person. As you can see, it says person.person with parentheses. So it's like, and you can also see that there is the method icon in there in that tooltip. So let's talk a little bit about constructors. We have one right here. If I delete it and then save, it won't complain, even though I killed the constructor right here. That was in this class. I killed the constructor, the default constructor. The reason is because all objects are in themselves descended from a sort of omni-object called simply object. And so what they all have from inheritance from that original object is a empty constructor. And so I can put it back, but it is generally good practice to keep it in. And if we want, we can create another one. Let's comment that out for now. Control K, Control C. Alright, so we've got ourselves a person class, as you can see. Everything about the person, or about the concept of a person, is enclosed within these parentheses here. Or excuse me, not parentheses, curly brackets. So, what else is there about a person? Let's do this. Let's go down the list of things. So, a person has a name, right? So, presumably of type string, name. What else does a person have? A person has an age. Let's represent that with a 32-bit integer. That's what int is. It's a 32-bit integer. we have, perhaps we can also do like a, we could do probably, we could do like color of hair. Oh, what class is, let's that in. Oh, it doesn't know what I mean. Never mind. This is good. This is good. Now, as I did this intentionally to illustrate something. If I go to Dave and type, say, age, right? Dave.age, it will not show up. It'll be like, what are you doing? What is this? What is this? So by default, these members of the person class are shown to be private. If I make them public intentionally, then I could probably go like console.writeLine Dave.age. I could do that then. Oh, also, this constructor right here is a private constructor because we didn't say public before it. There we go. It was letting us know right there. But this does not take, this making these public fields does not take advantage of encapsulation, does not take advantage of access control, and also it does not enable us to use setters and getters. So let's change this to a private string name and a private integer age, and then we'll make ourselves some setters and getters. So we can say public void set name, parentheses open. We're going to have ourselves a string argument called name, and then we'll create a body. This dot name equals name. Now, what this method does is it takes an argument called name, which is a local variable. It exists only in this. It exists only in this context. It takes name and it makes the class version of name, that is this name, right? So this specifically refers to this one up here, right? That exists in the scope of the class. As you can see, it says class test person right there. Whereas this one says parameter. So this method will take this name and it'll make the class version of that name equal the value of this name right here. Now you might be wondering, why do we use this? Well, if I don't put this there, then that's a little bit confusing. It'll say, it'll be very confused. One could also just like rename this. I could do that, then we wouldn't have to write this. That would work. But that's up to you. That's a matter of preference. Me, I prefer to make use of this, because it's the same idea. As you can see, we have a naming rule violation. Certain languages will have different standards, but the standards being violated will not necessarily affect compilation of code or cause a runtime error. So I renamed it to setName with capital S instead. Now let's do a getter. We just made a setter. This will set the variable equal to something. But let's make ourselves then a getter. So we're going to call this public string get name. And it does not need any arguments. And we'll say return this dot name. I could have also written simply name, because there would have been no ambiguity over which name we were talking about, because within the context of this method, there isn't any other name. But I'm going to do this name, because I think it's clean. Alright, let's go back to here. As you can see, saying Dave.age does not compute. It does not like it. It is inaccessible due to its protection level, which is good. Instead, we can say get... Oh, as you can see, we do not have get age yet. But I can write that. And I can say, okay, generate method for it. And it'll generate it for me. Granted, it'll be extremely bare bones, and it'll throw an exception. It'll throw a new exception. But we don't want that. We don't want it to throw a new exception. First of all, change internal to public. We don't want bool. I'm not sure why I thought we wanted a boolean. Let's write int. And then we'll write return this dot age. Now the nice thing about setters and getters is that they give you a lot more control over what a user does with a given class, what they can get away with. If we simply gave them public access to age, they could change age however they wanted. But right now we've made it so that they can only get the age. They can't set the age after the age has been set. Or maybe there's going to be another way of controlling it. Maybe there's a public void increment age, and it's going to do is just increase the age by 1. This dot age equals, or no, this is age plus plus. There we go. This means add 1 to age. Alternatively, we could say this dot age equals age plus 1, or this dot age equals this dot age plus 1. That's a more verbose way of saying it. That's why we're going to do age plus plus like that. So now the user can't specifically set the value of age to whatever they'd like. But what about when the person object is created? Right now how it goes is it'll call the default constructor, which we've written out here, but nothing happens in its body. So we can make it so something happens in the default constructor. We can make it so like if you call the default constructor, it'll provide default values. So in that case, we could say name equals John Doe and age equals 25. We could also write this dot name, but you get the picture. So let's talk about then making alternative constructors that may be called Gesundheit. This guy sneezed. Public person, and this is going to take advantage of operator overloading, or overloading, excuse me, the constructor. So with all methods, you can overload them by having simply different arguments available. So at the moment, it's complaining, oh, there's already this right here. Well, we can fix that. We can say string name. So this will become the version of person where we specify a name. We can make yet another constructor where we say person string name and then int age. We could also still set in this previous one a default value for age. we have all sorts of options here. And then within program.cs, we could say, instead of calling the default constructor here, we could make another person. We could say person Janet. I don't know who Janet is, but let's say person Janet. And as you can see, it'll say 1 of 3. We could go down and select some of the options. No, if I simply write 3, it won't like it. Because there's not a single constructor available where we can simply write the age out. There's one that will allow for a string, and there's one that will allow for a string and a name, and there's one that will allow for no arguments, but not one for just an integer. We could accommodate that, but let's not. Let's not and say we did. Here we go. Whoops. So we've thus far been using setters and getters, but one of the observations one might have is that they can get very verbose. They're very similar to each other, and they increase, or they take up a lot of space. So instead of using setters and getters, we can use something called properties instead. Now, properties are unique to C#. They don't exist in Java, if any of you are familiar with Java. But the way to do properties is you would say public string name. We're going to do a capital N to signify that it is in fact public. That's purely an aesthetic choice, but whatever. And then we'll say, and then we can say get turn this name. And if we want a set, we can say set this dot name equal to value. So this is a property for name, the name variable. It kind of puts set and get name out of business as they're no longer needed. They're kind of redundant with this around, but it kind of it's kind of cool. We can do it again for age, but we get the picture. Now let's show you what it looks like. So if I could say Dave dot, and I could say either get name or set name. As you can see, these are two options. Or I could say name. Dave.name equals I'm not sure who Dave Horowitz is. I feel like I've heard that name before. I don't know. Well, anyway, we've named it. Now this looks very similar to just calling. This looks very, very similar to if we just made this public and just referred to that. But the difference is this is still encapsulation. This is still encapsulated. We have the control of encapsulation. We have the control of accessibility. They can't change the original name, but they can change this. And we have more control. We could potentially do more right here. We could say for instance, we could do that. So console.writeLine Dave dot, and then we could say get name again. We could do that to show that it does in fact transfer over. Let's do a read line, a read key statement, just so it doesn't close the terminal window. So if I launch it, by pressing F5. I could also press start. We got some values printed, so we got Dave get age, so 25, and then we changed Dave's name to Dave Horowitz, and then we said Janet, and we're like, okay, let's get Janet's name. Oh, it's Janet. Okay, that's cool. And then we did Dave get name. Oh, look at that. Now, maybe I should, like, illustrate what his name was before, so... Let's use, just for the sake of it, let's use interpolated strings. So you put a $sign in front of the string, and inside the string you make curly brackets. And then I can say Dave.getName. It's cool. I like interpolated strings. Let's run again. So as you can see, it was Dave before, and then it became Dave Horowitz. Cool stuff.